Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gill Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how new ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries or constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gill@eapen.info. My guest today is Dr. Rory Cooper, who holds several positions, including Associate Dean for Inclusion and Paralyzed Veterans of America, Professor of Rehabilitation, Science and Technology, and Orthopedic Surgery at the University of Pittsburgh. He is also the founding director and the VA Senior Research Career Scientist at the Human Engineering Research Laboratories. He is also a professor of physical medicine and rehabilitation at the Uniformed Services University of the Health Services. Welcome, Rory.
Welcome. It's a pleasure to be with you, Gill.
I want to rewind time a bit to the early 80s. And, if you could talk about what happened in the early 80s. You were a young recruit into the U.S. Army, positioned in Germany. And what happened there and what led you to the career that you are currently in at the University of Pittsburgh.
Well, thank you. Well, basically what happened is that I had suffered some knee injuries, and so therefore, in order to try to recover, I was bicycling rather than running. And I one day, actually July 23rd, 1980, nearly 40 years ago, I was out exercising on my bicycle when I got sideswiped by a bus and then hit head on by a truck. And it caused me to have multiple injuries. Most severe and lasting among them was a spinal cord injury. And I was, after several months of hospitalization and rehab, I was sent home. And a few months later, I started college at California Polytechnic State University in San Luis Obispo, California, where I later earned a bachelor's and a master's degree in electrical and computer engineering.
Yeah, so your interest in this area started then, in terms of in the area meaning wheelchairs and generally rehabilitation services and technology.
Yes, it started actually for a couple of reasons. One of them is that I realized that I'd have to. If anybody knows the topography of Cal Poly, it's built on a hillside, and that I'd have to be able to push around campus and get up and down those hills.
Yeah.
And so I started pushing the chair I received, and it fell apart within a few weeks. Just much like a hospital chair, the chair you would see in hospitals to move patients around today. And it really wasn't suitable for a young active person, or actually anybody that wants to be active and participate in various aspects of society. and so I was fortunate that my friends in the Army and they did a fun run and raised some money to buy me my first sports wheelchair, which is a quadro wheelchair built by an athlete called Jeff Minnebraker. Later, I took that and started building my own wheelchairs as I got more skills from engineering school.
Right. Yeah. And wheelchair is a complex machine, right? Because it has to really do variety of things, right? Could you talk a little bit about, sort of the architecture of the wheelchair itself?
Yeah, well, actually, we should talk about wheelchairs in two broad ways. There are manually prepared wheelchairs, essentially wheelchairs you propel yourself. And in a few rare cases, there's wheelchairs that are attendant propelled. They're used mostly by younger people, by kids, and in some
Yeah.
cases by adults where they can't use a power chair, but that's fairly uncommon. And there's powered wheelchairs. So we just start with powered wheelchairs for a moment. They're essentially mobile robots,
Yeah.
and they're probably the most prolific mobile robots on the planet, I would say, uh, because there's literally hundreds of thousands of them in use, and they provide daily mobility to people with very complex disabilities, and so and they're every year they get smarter and have more robotic features, um, such as obstacle avoidance or obstacle negotiation, object recognition. But even the simplest power wheelchair has pretty sophisticated user interfaces and also controls for controlling controlling the speed and acceleration and direction, because they have to be able to interact safely with other people in the environment, for that matter, people, children, and pets, and family members, and just people in public spaces and down on public sidewalks. Manual wheelchairs, though, you would think would be simpler, but in many regards are just as complicated, but the challenges are more based on the ergonomics.
Yeah.
So you have to make them, typically the goal is to make them light, stiff, maneuverable, and such that they support the person for a good seating position and posture, but also not damage the upper extremities, so primarily the wrist, elbow, and shoulder for due to repeated motion. That's another thing that it's often overlooked when the people that are not clinicians or expert users or engineers that are involved in the field, that from an ergonomic perspective, manual wheelchair propulsion is a very challenging task, because people typically, when they push their wheelchair daily use, their arms contact the push rims, which are the devices that you use to propel the wheelchair forward, thousands of times per day. So it's a pretty strenuous ergonomic task from that perspective as well.
Have the materials changed over time?
Oh, yes. Actually, the material changes are, in many regards, I would say, second to the better understanding of the ergonomics. The material changes have also been um, essentially equally important in the evolution of design of wheelchairs. So the first wheelchairs, all the way up actually until about 1930, were primarily wood. In some cases, they had even a little bit earlier, in the early 1900s, they did have some steel spokes, but adopted from bicycles at the time. But now the wheelchairs, then of course in the 1930s, Herb Everest and Harry Jennings came up with the first steel folding wheelchair, which actually became the dominant wheelchair on the market all the way up until the early 1980s. And then at that time, people started to experiment with other materials. At first, aluminum became available, more widely available, and also the tools to shape and to weld aluminum became more widely available, more knowledgeable. And aluminum wheelchairs are still very ubiquitous even today. But other better steel materials, the aircraft industry, also widely populated chromium, molybdenum, steel, also known as chromoly. That's actually a very good material for making both manual and power wheelchairs. And it's interesting because of the high strength of steel, you can use less of it, and you can pretty much make a very lightweight steel wheelchair or a very lightweight aluminum wheelchair, depending on the design features. And then really actually in the 1990s and early 2000s, titanium became available. And titanium is also is now fairly widely used in manual wheelchair design. Titanium has several desirable properties, and one of them is that it doesn't rust, and neither does aluminum really, but it's also pretty wear abrasive. So when if somebody by accident, for example, when loading it in a car, scrapes the frame along the street or the sidewalk, you can kind of polish it out again with an abrasive pad. And so so that is a pretty nice feature to it. It's also very lightweight, and then it's has a little bit of a spring to it, and so they're among the high end power manual wheelchairs. You see a lot of titanium. Now power wheelchairs are mostly steel and aluminum, which makes sense. They don't have the same weight constraints, although oddly enough, or interestingly enough, that's becoming more of an issue today. People would like to see lighter power wheelchairs that they can more easily transport.
Yeah. And I guess the optimization there would be cost also, right? So titanium, I would imagine, is more costly.
The interesting thing is titanium is more costly than aluminum, and aluminum is more costly than steel. But the amount of titanium, aluminum, or steel in the wheelchair itself is a small fraction of the overall cost.
Okay. And so this is only one of the modalities that you are doing at Human Engineering Research Laboratories at University of Pittsburgh. Could you talk a little bit about all the various activities? I know that you are pursuing sort of full-fledged robotics in various activities. Could you talk a little bit about that?
Sure. So it's difficult to talk about all the projects because we have about 80 ongoing projects.
Yeah.
But if the ones involving robotics, I think one of the things I think that I'm very pleased with is that we developed the robotic assisted transfer device, also known as strong arm, which has actually helped pioneer the field of powerful robots in close proximity with people. So we started on that project about 15 years ago now. It's actually been licensed to RE Squared or RE2, which is a local robotics company in Pittsburgh to do the manufacturing and sales. But the strong arm, what's unique about it is it has the ability to lift a person out of their power wheelchair and then transfer them onto another surface like a bed or a toilet, which allows people to go out in the community and go shopping with their family or stay in a hotel or visit family or friends overnight, and without having to take a bunch of different other equipment or have their friends install equipment that they wouldn't otherwise need to use.
Is it something that is it, so sorry, Rory, is it something that's attached to the wheelchair, or is it a different equipment altogether?
It attaches to the wheelchair, and that's one of the bases, because you don't have to have a separate base of support. You use the power wheelchair as the base of support.
Yeah.
And then it's ambidextrous. In other words, it can be on the left side or the right side of the wheelchair that runs on a track that allows it to be positioned in the back so it's out of the way when it's not in use. Of course, it can be removed if you're not going to use it for an extended period of time. Or, for example, if you're going to travel, then you can pack it in a box and take it as luggage or ship it ahead of time if that's what you so desire. And then it lifts the person. We'll also work with a company out of Canada called Kinova for a wheelchair-mounted robotic arm, but it also can be mounted on another surface. And that allows individuals to do manipulation tasks. So like eating or meal preparation, or simply if you don't have the ability to use your arms, if you drop a book or drop your smartphone, then you can use it to pick it up. Or and so we've developed a lot of different control interfaces, and also made the work with them to make the robot much smarter. So, for example, we have a smartphone interface or a tablet interface that makes it intuitive, where you can just use your finger to control the robot arm. So, and then also along the same lines, you can do what's called visual servoing. So in other words, you see an object and then you can have the robot kind of servo in on the object, which makes the control a lot more intuitive.
Right.
And we also work on mobile robots. Back in the 1990s, we worked on the iBot, which is now brought to market by for a while it was on the market by Johnson & Johnson, and then it went dormant for a while. Now it's back on the market through Dean Kamen's company up in New Hampshire. And that's a robotic wheelchair that can balance on two wheels. You're probably much more familiar with the iBot's cousin, the Segway.
Oh, yeah.
So we worked on both of those projects. The iBot is now back on the market, and that's a pretty cool robotic powered mobility device, because it can balance on two wheels, it can climb 4-inch curbs, it can do self-leveling in the fore and aft directions, backwards and forwards. Based on the shortcomings of the iBot, we started developing the MeBot. And the MeBot is the mobility enhancement robotic wheelchair, which can self-level, or what they call attitude control, forwards, fore aft, and left right, so laterally and fore aft, and or pitch and roll, depending on your perspective. That allows people to go up a ramp or down a ramp or a cross slope. And what's really exciting about the MeBot is, even if you are driving down the sidewalk and you try to avoid hitting a person, for example, and you swerve towards the street, you can actually catch you if you drop one wheel off the curb.
Yeah.
So you can drive with one wheel on the curb and one wheel off the curb. So you can get to a position where you can get both wheels either on one surface or the other surface. And it also can climb 8-inch curbs. And it has all full seat functions. It's got lateral tilt, forward tilt, leg rest elevation, backrest tilt, backrest recline, and then also a seat tilt, which allows it to accommodate individuals with very severe disabilities.
Right, right. One of the challenges I would imagine is really the human machine interface, right? And I know that you're doing a lot of work in that area. How does the human interact with the machine? And I also wondered, are the projects also focused on, we increasingly see a lot of artificial intelligence applications, right? So can the chair actually learn the habits of the human over time and become smarter and smarter? Are there developments in that area as well?
So that's a great question. And so, yes, I actually would argue that, well, I know in assistive technology, we have probably the most widely used AI product, and that's the virtual seating coach, which
Yeah.
is available on all Permobil powered wheelchairs. And it uses AI to exactly that, not only to learn a person's habits, but to use what called virtual coaching to try to to encourage people to perform more healthy activities. We're trying to do in this case maintain health of the soft tissue in the seated areas or to prevent lymphedema. And it can be also used for other conditions as well. But what it does is it studies your habits. So not only the habits for your use of your power seat functions, but where you go and when you go, and tries to learn when are you most likely to be susceptible to coaching. And then at that time, provide instruction on how you might better contribute to your improving or maintaining your own health. The MeBot also uses AI in order to determine your intent in a complex environment. So try to explain that. Basically, let's say you're crossing let's say there's no curb cut on a busy intersection, and you want to cross the street. Then MeBot incorporates software that where it would see there's a curb in front of you, and based on your behavior in the environment, would start to do the path planning to climb that curve, because it would be learning to know that based on your behavior and the environment, that's probably what your intent is.
Right.
And then it can start preparing. And the idea is if it can start preparing, then you can climb the curb faster and cross the street faster and reduce your risk of getting hit by a vehicle, for example.
Right. And audio is becoming more of a mechanism for communications with machines, right? Granted, the demise of the computer mouse is probably greatly exaggerated, but we are increasingly talking to the machine. And I would imagine, there are developments in that arena too, right?
Well, I would actually say it goes both directions.
Yeah.
The machine talking to us and us talking to the machines. So that's certainly an area as well. I think the real benefit there is the smartphone being not only being a fairly powerful computer itself, but connected to cloud computing to even more powerful resources. And the fact that there's a lot more natural language learning algorithms being developed. And so we are obviously taking advantage of those for the various types of robot control. They're a little trickier for outdoor mobility because the ambient noise and other people talking and things like that. But
Right. Yeah. And autonomous vehicles, for example, there is a lot of talk about fleet management. And I don't know what the numbers are, Rory, but the how many wheelchairs are in operation in the U.S. approximately?
About 4 million.
About 4 million. So that's not a small number. Do you see, the wheelchairs communicating with each other, or is that something that is probably way into the future?
Um, that's a funny question because we have actually investigated that.
Yeah.
So in some ways, I would say so. Wheelchairs less communicate with one another, but a lot of wheelchairs now communicate with with the manufacturer.
Mm.
Do you think more like cars started
Yeah.
out by communicating with the manufacturer, or so for example, if the so you could do predictive maintenance, for example.
Right.
So you get the wheelchair repaired before you need it to be repaired, right?
Right.
So it's better to have it repaired the day before you need it than it does to have it broken down somewhere. And then also that they can um, communicate based on usage, right? So it's the same basic concept, but more like for when you need the wheelchair repaired, or when the wheelchair needs to be replaced, or batteries need to be replaced, some component like that. What I actually think is a little more interesting problem is what you alluded to with self-driving cars.
Yeah.
So as there are more autonomous vehicles, even lower levels of autonomy, not completely autonomous vehicles, that's provided the opportunity for more people with disabilities to drive with a restricted license.
Right.
But I also think, eventually we have to look at um, making sure that autonomous vehicles are also accessible vehicles. So
Yeah.
if I use a wheelchair or a walker, or um, I'm visually impaired or hearing impaired, that I can communicate with and then access autonomous vehicles. Even in the short term, to do that, improve those services through ride sharing. At least with ride sharing, there's a human driver that you can kind of explain your needs on the fly.
Yeah.
When it's a completely autonomous vehicle, then you need to have communication. And that's where I think it's important is that the wheelchair talk to the car, for example. Say, I'm this kind of wheelchair and I have this kind of uh, tie down system, and I need this type of occupant restraints, right?
Yeah.
And then you
Yeah.
can send the right vehicle, and the vehicle and the wheelchair can communicate. And actually, when you got close, the wheelchair and the vehicle could potentially communicate to help with ingress and egress and docking.
Right. Right. And I think in the, just thinking about this in the smart home context, we're all getting older. Yeah. And so, wheelchairs could become sort of an essential component of a home when there is a mobility issue as people get older, going up the stairs, variety of movements. And we have now ways to gather wearable technologies, ways to gather health related information as well. And so I think there is sort of an environment being created inside the home that requires perhaps a wheelchair or wheelchair like modality to be present. I'm just speculating.
No, I think that's an excellent idea, and we actually are doing research in that area as well, where we're using um, basically trying to get to merge assistive technology like wheelchairs and wheelchair mounted robotic arms with ubiquitous home automation technology.
Yeah.
And so devices that do control the home environment, like lighting and temperature, and for that matter, people's television, and provide music and all kinds of other ability to open doors and close doors. All of that makes a perfect sense. And if they know that you're a wheelchair user, then it can help interact, right?
Yeah.
For that matter, it can also help from a health perspective, like you mentioned. So the idea of what is called aging in place, right? Allowing people to stay in their homes
Right.
as long as possible. In these home automation systems, talking to the wheelchair, for example, if they find out that the wheelchair hasn't moved for quite a while, right? Then
Yeah.
that's a good indication that there
Yeah.
might be some sort of health issue going on.
Right.
So,
Right. Exactly. Yeah.
well, if the wheelchair is located next to the bed and hasn't moved for a day, right? That's kind of an
Right.
extreme case, but that's probably a good reason to have somebody come in and intervene.
Yeah. I mean, you could also, you might be able to build in things like temperature, blood pressure, heartbeat, and things like that into the modality too. And
That's
so,
exactly right.
yeah,
Actually, we just recently wrote a grant to actually having a wearable garment, right?
yeah,
That would measure those physiological signs. And then obviously, the nice thing is you've got this mobile robot that you're riding around in a power chair at least, right? And
right.
then you could have your garment talk to your wheelchair, and for that matter, could talk to your home automation system and say, um, we need to get you some help.
Yeah, and from a production standpoint, Rory, is 3D printing pretty close for something like this?
Actually, yes. 3D printing is actually, this is probably one of the better areas for 3D printing because there's so many. 3D printing is very good when you need small numbers of highly specialized um, devices or components.
Yeah.
And that's exactly what most people with disabilities need when there is to in order to customize the technology to fit an individual's needs, as we talked about earlier on the ergonomic side,
Yeah.
right? And so that's where 3D printing is excellent. So, and we use 3D printing extensively in our lab. Um, Literally, we make tens of thousands of 3D printed parts per year. Right now, even more because we're making swabs for COVID-19 for the VA. But even in our assistive technology work, it's a great way to make a device affordably and in a fairly rapid turnaround for an individual. So I'll give you an example.
Yeah.
Recently, we had a veteran who lost both of his legs in Afghanistan and also had a traumatic brain injury. And he lives at home with home automation technology, for example, a speech system that allows him to unlock and lock doors and open doors in his house. Um, but also, they recently, his wife became pregnant, and he would like to participate in childcare.
Mhm.
So we worked to modify a car seat, a child car seat, to attach to his wheelchair so that he can um, take his child out, so he can change the baby's diapers and take her out for a walk, or and that we used a lot of 3D printed and rapid prototype parts.
Yeah.
And so then that's allowed us to do that development for him and his wife and child, obviously, very quickly. And then the nice thing is it comes off, and the wife can put it in the car as a child seat as well. and obviously, um, that wouldn't be so cost effective if it weren't for not only 3D printing but flexible manufacturing technology.
Right.
And so, like computer numerically controlled machines that allow you to quickly make all kinds of different parts and components without having to develop a lot of specialized tooling.
Yeah, yeah. And so in conclusion, Rory, if you look forward 5 years from your lab perspective, from human engineering research lab perspective, where do you see the most important innovations are likely to be?
So I think they are likely to be in the areas of robotics, automation, and uh, and machine learning.
Mm.
And I think we'll see those applied to um, uh, both independent living and mobility. And I use the term mobility because I've talked about mobility in the home, mobility in some on roadways or motor vehicles, airline transportation, public other forms of public transportation such as buses and trains as well.
Yeah, yeah. Computer assisted mobility becomes a more general area, I would imagine, right?
It does. And I actually think all of us I think that we're all merging towards computer assisted mobility
Yeah, yeah,
using GPS navigation and route planning and communicate and on demand vehicles to allow alerting buses, all of those, it's all merging. The idea is that computer assisted mobility um, becomes merged with mobility for people with disabilities and older adults.
yeah. Yeah, this has been great, Rory, and thanks much for the time that you spent with me, and good luck with all the projects, all 80 of them that you're pursuing at Pittsburgh.
Thank you very much, Gill. It's been a pleasure to be on your podcast.
Thank you. Bye.
Bye.